So in this final video, we'll see how to use the partial fraction decomposition to find the antiderivative of a complicated fraction. So I hope that you recognize that this is the fraction that we found the partial fraction decomposition for. So let's write that out and use that to rewrite the. Now, because of the rules of integrals, the integral of a sum is the sum of the integrals, we can split this integral up into four pieces. The first antiderivative that we have to find is the antiderivative of 1 over x minus 1, and then we have to multiply that times 5 because of our coefficient. The second antiderivative that we have to find is the antiderivative of 1 over x plus 1. And we have to multiply that antiderivative times 3. Then the third part is where we have to find the antiderivative of 1 over x plus 1 squared. We have to multiply that by 4. And then finally, the integral that we have to find is an integral that we can split up into two pieces. Remember that was a trick before where we split up the numerator. So we have 1 times the antiderivative of x over x squared plus 1. And then the second part of the numerator gives us 2 times the antiderivative of 1 over, and I'm going to rewrite the denominator as 1 plus x squared dx. So now let's find these integrals. The first integral is the antiderivative of 1 over x minus 1. And if we use a u substitution, u equals x minus 1, we see that we have to find the antiderivative of 1 over u, which is the ln of the absolute value of u. So our first integral becomes 5 times ln of the absolute value of x minus 1. The second part will give us 3 times the natural log of the absolute value of x plus 1. Now for the third integral, we can use a substitution u equals x plus 1. Du dx is just 1, so we don't have any extra terms, and the integral would change into the antiderivative of u to the power negative 2 du. So we can apply a power rule there, and that gives us, for the third part, that we have to add 4 times and then negative 1 over x plus 1. For the fourth integral, we can now use a substitution. And the substitution for the fourth integral would be u equals x squared plus 1. So du dx then gives you 2x, and that cancels with the x in the numerator. So pause the video and see if you can actually verify this yourself. But the fourth part of the integral then gives us 1/2 times ln of x squared plus 1. And then the last integral that we have to look at is the antiderivative of 1 over 1 plus x squared. And I hope that you recognize that as one of the basic antiderivatives. The basic rules on your handout is what I mean by that. And that antiderivative is given by the arctangent of x. And so we have to multiply that by 2 and then add a constant of integration. And so the method of the partial fraction decomposition has allowed us to find the antiderivative by breaking down that complicated fraction into partial fractions. And this is our final answer.